Hummingbirds are a fast and fascinating family of animals. Being as small as 1 inch, weighing as little as just 2 grams, and eating up to 3 times their body weight in food every day, they are one of the most extreme birds there is. Their unique lifestyles are made possible by a number of equally unique adaptations. The most immediately noticeable is their agility. Capable of flying backwards, upside down, or hovering perfectly still, their movement is unlike any other avian's. This fancy flying requires a lot of energy, and so their metabolism flips between extreme highs during the day and extreme lows at night. Additionally, there are a number of adaptations in their tongues that help them actually access the nectar in flowers. Hummingbirds are very unusual birds, and they possess a number of traits that make them highly specialized for their specific niche. A hummingbird's aerial mobility is by far their most well-known trait, due to their tendency to zip around flower gardens or dedicated feeders put out for them. This speed helps them jump quickly from one flower to another and stay there without having to land. Hummingbirds manage this by beating their wings 12 to 90 times every second, an act that causes the signature humming sound that got them their name. Additionally, hummingbirds can rotate their wings more than most birds, which allows them to create lift on both the up and down strokes of their flaps. When done rapidly, this rotation can cause a hummingbird to hover in place, almost unmoving. When they want to start moving, they can vary the speed, intensity, or path of each wing's movements to reach a speed of up to 33 miles per hour. According to one study on hummingbird turning by Segre et al., hummingbirds can generate a centripetal acceleration of 20.1 meters per second squared. A car accelerating forward at that rate would have a 0 to 60 time of just 1.3 seconds. All of these flight abilities make them uniquely mobile amongst avians, allowing them to access their food source very efficiently. But there is, of course, a trade-off. Flying takes a lot of energy, and flying like a hummingbird does takes even more. According to UC Davis's Hummingbird Health and Conservation Program, a hummingbird's flight muscles make up 25 to 30% of their body mass, whereas other birds average 15%. All of this muscle requires constant energy, which is why they need to eat so much nectar. Nectar is mostly made of sugars, making it very energy dense, and hummingbirds have evolved a digestive system capable of processing the sugars in nectar better than other birds could. Despite this, hummingbirds still use so much energy that they need to constantly be eating. Since even a few hours without food can be fatal, hummingbirds sleep by going into a sort of nightly hibernation called torpor. They drastically lower their heart rate and body temperature and become virtually unresponsive, which, according to a paper by Shankar et al., decreases energy costs by around 82%. This torpor is what allows them to sleep through the night without starving to death. The hummingbird's lifestyle causes their metabolism to be incredibly high during the day and to decrease to as little as 1/5 of that during the night. While these wild fluctuations may seem excessive, they are necessitated by the way their bodies function. Like most things, hummingbirds need to eat to survive, and they do this by using their tongue to lap up the nectar found in each flower they visit. But this tongue is no ordinary tongue. For starters, when not extended, it passes through the bottom of their beak, travels fully around the skull, and passes back through the nostril. It is also divided into 2 tube-like sections, which fully split apart near the end. These bifurcated tips are covered in feathery structures called lamellae that help capture additional nectar. The whole process of taking in nectar is similar to a pump, except that it happens 15 to 20 times every second. First, the wet tongue is extended towards the nectar with the tubes compressed and held shut due to surface tension. Then the tongue hits the nectar and the tubes expand and open, pulling nectar back and up into the tongue. At the same time, the bifurcated tip spreads out and the lamellae serve to capture additional nectar that may be hard to reach otherwise. The tongue is then withdrawn, the tubes closing as they leave the nectar and get once again exposed to the air. When closed, the tongue tapers to a point, preventing any nectar from leaking out on the way to the mouth. The tongue is then pulled fully back into the beak and squeezed out. This elaborate pump system is what allows them to drain hundreds of flowers of their nectar each and every day, and is how they get the food required to keep up with their insane metabolism. Hummingbirds are birds that have evolved to be completely specialized for one specific niche. Their body plan allows them to move quickly from one flower to the next, and in return, their body burns through the fuel they get extremely quickly. So quickly that they will go into sleep plus just to avoid starving in the night. Their tongue also helps in the collection process thanks to a number of different structural features that allow it to draw up large amounts of nectar very quickly. There are trade-offs and benefits to each of these remarkable features, but each one is a key trait that makes a hummingbird a hummingbird.